All right, if you're a developer, you've probably built dozens, maybe hundreds of so-called REST APIs. I know I have. But what if I told you that most of us, for years, have been getting it fundamentally wrong? That the vast majority of APIs we call RESTful actually aren't? We're going to fix that today.
Yeah, this quote, that's me. I'm calling myself out. For years, I was building APIs, calling them RESTful, thinking it just meant, shipping some JSON over HTTP. And then I actually went and read Roy Fielding's dissertation, the paper that invented REST. And, oh man, it was a huge light bulb moment. I realized I was missing the most important parts. And I've got a feeling I'm not the only one.
So to really get this, let's just forget about code for a second. The best way to understand the core shift in thinking is with a simple analogy, a public library.
Okay, so on the left, you've got what's called the RPC approach. It's like walking up to the librarian and giving them a list of commands. Find the elephant book and check it out for me. You're focused on telling them what to do. That's an action. Now, the RESTful way on the right, that's totally different. You don't boss the librarian around. You interact with the system of the library. You look for the animal section. That's a resource. You find the book's specific location on the shelf. That's its URI. And then you take it to the checkout desk. That's the action you perform, your HTTP method. See the difference? It's about navigating resources, not calling actions. So what actually makes an API RESTful? Well, it's not about JSON. It's not even really about HTTP. REST is an architectural style, and it's defined by a specific set of rules or constraints. Think of these 6 rules as the missing manual most of us never got. If your API breaks these rules, it's not really a REST API. It's something else. There are 6 of them in total. 5 are absolutely mandatory, and 1 is optional. Let's break them down one by one. First up, client-server. This is the one we all kind of do by default, so good job us. It just means the UI, the front end, is separate from the data storage, the back end. This is huge because it lets your mobile team and your server team work on their own stuff without constantly breaking each other's code. Second, and this one's critical, stateless. This means every single request from a client has to contain every piece of information the server needs to understand and process it. The server shouldn't have to remember anything from the last time you called. I like to think of it like this. Every request is a first state. No history, no what we did last time. This is a game changer for scalability because any server in a cluster can handle any request at any time. Number 3, cacheable. Let's be honest, network calls can be slow. REST is built with this in mind. It says that every response has to explicitly label itself as either cacheable or not. If it is, clients and proxies can store that response and reuse it later. This cuts down on traffic, reduces latency, and just makes everything feel way snappier. Fourth is the layered system. This one's pretty cool. It means the client has no idea if it's talking directly to your API server or if there's a load balancer, a cache, or security gateway in between. This is awesome because it means you can add all these extra layers for security or performance later on, and you don't have to change a single line of client code. Okay, number 5, the uniform interface. If you only remember one thing from this whole explainer, make it this. This is the single biggest, most important constraint, and it's the one that almost every so-called REST API gets wrong. This is the secret sauce. And this uniform interface has 4 subrules. First, we identify resources with URIs, like /users/123. Simple enough. Second, we use standard representations like JSON to manipulate those resources. Third, messages have to describe themselves, like using a content type header so the server knows it's getting JSON. And fourth, this is the one with a crazy name that everyone ignores. Hypermedia as the engine of application state, or HATEOAS. We are going to circle back to that one because it changes everything. And finally, the 6th constraint, which is totally optional, code on demand. This just means the server can send back code, like JavaScript, that the client can then run. If you've ever built a modern web app, you're already doing this. So, no biggie. Okay, that was a lot of theory. Let's make this real. How does all this stuff actually change the code we write every single day? Let's look at some before and afters. This right here, this slide, is the aha moment. On the left is what so many of us build. Look at those URLs. Create user, get user. They're verbs, they're actions. That's RPC style thinking. Now look at the right, the RESTful way. The URLs are all nouns, users, /users/123. They identify things, not actions. They're resources. So if the action isn't in the URL, where is it? The verbs are the HTTP methods themselves, the ones that are already built into the web.
Get is for retrieving, post is for creating, put is for replacing, delete is for deleting. We don't need to invent our own action names because HTTP gives us a universal, standardized set of verbs to use on our resource nouns. It's so simple and elegant once you see it.
And another huge part of that universal language is using status codes correctly. You know what I'm talking about, the classic 200 OK response that has an error message in the JSON body? No, the status code is the response. 201 means I created it. 404 means it's not here. 400 means you messed up the request. Using these is absolutely non-negotiable for a real REST API.
And now for the final boss, HATEOAS. It sounds scary, but the idea is actually revolutionary. A truly RESTful API doesn't just send back data. It sends back data and links that tell the client what it can do next. So here, we don't just get the user's name. We get a link to view their orders and a link to update their profile. This is a game changer because the client doesn't have to hardcode URLs anymore. The API guides the client. If you change your URL on the back end, the client doesn't break. It just follows the new link. Your whole system becomes incredibly resilient. And this quote just nails it. If your clients need to read separate documentation to figure out what URLs to call, you're not doing REST. The API itself should be discoverable. It should tell the client what's possible. All right, I know that was a fire hose of information. If your head is spinning a bit, that's okay. Most of us learned this stuff wrong, so it's a big shift. Let's boil it all down to 3 simple things you can remember and start using right away. First, REST is defined by those 6 constraints. It's a design philosophy, not just sending JSON over HTTP. Second, think in resources, nouns, not actions, verbs. Let the HTTP method be the verb. Your URL should identify things. And third, use the whole HTTP tooldocs. Methods and status codes are your best friends. They are a fundamental part of the API contract. So I'll leave you with this challenge. Go look at the last API you built or worked on. With these 6 constraints in mind, how many does it actually follow? Is it stateless? Is the interface uniform? Does it use hypermedia? Be honest with yourself. The answer might surprise you, but now you know the path forward to building systems that are more scalable, resilient, and truly RESTful. Thanks for watching.